Rumaza, what about others? It seems that I'm asking some alien thing. Did
Sir,
we?
we can.
Sir, yeah, say. Last
Oh,
time
sir.
we studied the conservation of momentum, right?
Yes.
So what now? What we have to study now? Conservation of momentum. Do, do we studied the equation of motion? I think all we studied all, right? This was the last day class, right? We solved this problem last time.
Sir.
Oh. The required velocity of itna kg of 4. We solved such problem last time. First of all, you guys open your cameras, okay? Otherwise, it is looking like a blank. You have to open the cameras, okay? Only one camera you have. So what did we study last time? Jabbar, you have to open the camera, right? Riaz, have to open the camera, right? Did we solve this question? Find the recoil velocity of gun having mass 5 kg. If a bullet of 25 gram acquires the velocity of 5, then after firing, what will be the? Did we solve this question last time?
Yes, sir.
So what about Avani? You got the answer? You got the concept as well?
Sir, got the concept.
Okay. So this was about the recoil velocity. So further we will move on. Muhammad, you have to, Riaz, you have to on the camera, okay? And Rumaiza, you two have to on the camera. Okay, good. So this equation, further if I'll write this equation, what is conservation of momentum? There is a term called angular momentum as well. Okay, but we are only studying here the conservation of what is happening this? So we have to study the conservation of angular momentum. Okay, sorry, I'm again saying angular momentum, but it's only momentum. Conservation of CONSERVATION, conservation of momentum. What is happening? momentum, conservation of momentum. What do we mean by, or what you understand the meaning of conservation? What is the meaning of conservation? Rumeza, what is meaning of conservation?
Saving something for the future.
Yeah, of course. Conservation of wildlife, conservation of water resources, like so. It means that at least what we have got from our forefather, we have to preserve the same amount for our coming generation. This is the meaning of conservation, at least. If you got 5 rupees from your father, okay, you have to save that 5 rupees for your sons. Okay, you don't have to waste those money. At least you have to save that. That means the conservation, right? So it means that what is the momentum before collision, if two object is colliding, okay, these are going this way and this is going this way. The screen is visible.
Yes, sir.
Okay, so if these two objects, suppose having some certain masses m1, this has mass m1, this has mass m2, this is going with velocity say v1, and this is coming with velocity say v2. So what does conservation of momentum says that the total momentum before collision, before COLLISSION, before collision will be equal to when it will collide. Now it is collided, two object is collided, right? So how it is collided? You have seen that you take the mud, okay, clay, got the point? And you see that the fan blade is rotating. You just throw the mud so as that the mud or that clay get attached to the fan blade. So what will be happening now? The clay and fan blade will be rotating with same speed, right? This happens. Did you get the example? Jabbar, did you get the example?
Yes, sir.
Okay. Rumaza, did you get the example?
Yes, sir.
So clay get attached to the fan blade and it rotates with the same velocity. That's one thing happens. Another thing happens that instead of clay, you throw a hard ball on the fan blade. So what will happen? The fan blade will get deflected and ball will get deflected back, right? So in both cases, the collision is happening. In first collision where there is mud or clay, that fan blade and clay is moving with the same velocity. Okay. And that's called the elastic collision. You got the meaning of elastic collision? Then the both objects move with the same velocity. Like that. If these two objects are colliding, okay, and this is moving with the same velocity, suppose v, final velocity is the common velocity, then it will be elastic collision. Okay. If after collision, you got the concept of elastic collision?
Sir.
Everyone?
Yes, sir.
Okay, so can you write in your own words? If the object after collision moves with the same velocity, then it's called elastic collision. That two objects stick together and moving with the same velocity. That's called the elastic collision, right?
Yes, sir.
So got the point? You make in your own words, okay? Write in your own words. Jabbar and Riaz, at least you two guys are not allowed to shut your camera. There is some, what can I say, benefit for Rumaiza and Avani, okay? But for Jabbar and Riaz, Jabbar, last time your father called me and told that he shouldn't shut down the camera, right? You remember? So the elastic collision is elastic collision when object moves with common velocity. When objects moves with common velocity. Common velocity, right? Like in this case, when two objects collides, okay, and after collision, they will move in the different ways. Let's see, this will be V1 prime. This is different from V1. And this will be V2 prime. This is again different from V2. If two objects are moving with different velocity after collision, then it will be inelastic collision. Inelastic. In E-L-A-S-T-I-C, inelastic collision. Means when objects after collision, after ULI collision moves with different velocity, right? Here we have to again add when objects after collision, after collision, right? So concept is clear? Riyaz, concept is clear?
Yes, sir.
Then tell me what is elastic collision? Riyaz, what is elastic collision? What is elastic collision?
Yes, sir. When object after collision moves with common velocity.
Any example? Any example?
Sir, clay when it is going. I forgot.
You have some sticky object, okay, like clay, any sticky, okay, like mm, a piece of floor that we use to make chapati. If a car is moving, you will throw on the window, that will stick. So there is also collision, but the both will move with a common velocity, right? Avani, what about the example of inelastic collision? What is definition and example? This time, Avani.
Sir, one minute. Sir, rubber band.
Rubber band. What will you explain it? I didn't get the full meaning.
Sir, like if we stretch the rubber band together, it will have the same at the same time if we stretch it.
No, where the collision in between rubber band. We are talking about in concept of collision. Okay, when two objects are colliding, the central theme of this talk is the collision is the central theme, and we are saying the situation before collision and situation after collision, right? Got the point?
Yes.
Yes.
If the rubber band has something to do with the collision, then we will bring that in our canvas, right? So did you find anything in rubber band with collision? Jabbar, your face is not coming. You are doing parda. So did you find any connection with rubber band with collision? No, na? Avani, you didn't given me the definition of elastic collision. What do you mean by that?
Sir, you want definition, right?
Yeah, right.
So, it's when, yeah, it's when two things have the same common velocity.
That's the elastic collision, right?
Yes.
Elastic means that the two objects are being attached together, glued together. What about inelastic collision?
Objects after collision moves with different velocity.
Right. So the conservation of momentum now comes. The total momentum before collision should be equal to the total momentum after collision. Equal to total MO momentum after COLLI. What is the meaning, spelling of collision? COLLI SI1, right? Single S.
Yes.
Okay, so this is the single S only. You got the meaning now? What does the conservation of angular momentum says?
Yes.
So now we'll try to make some more visualization. Some more visualization means, suppose suppose we have this frame, okay? These two objects moving toward each other with velocity v1, v2, mass is m1, mass is m2. So before collision, the momentum of each particle is what? Before, I'm writing just BEFORE before COLLISION collision. Before collision, momentum is what? Before collision, momentum. What is momentum? How we define the momentum?
The product of mass and velocity.
So mass of first object, velocity of first object, and we will give the sum sign, mass of the other object, velocity of other object. This is
Other.
before collision, right?
Yes, sir.
What about the after collision? We are considering inelastic collision. So now after the colliding, this will be going this side and this will be going this side. This is inelastic collision. Inelastic collision. Make the subheading, okay, inelastic collision. So the mass will remain m1. Okay, now make it m2 or make it m1 as well, no problem. Its mass will be m1, right? So these two objects are colliding and they are going in the back direction. Let me make it m1, m2 as it. So now this will be m1, this will be m2, this will be v1. But this v1 is different from earlier velocity. So we will say it v1 prime. No problem. It is just naming, right?
Yes.
And this will be going with v2 prime,
Excuse me.
right? Because v1 and v2 prime are different. The velocity after collision and velocity after collision, before collision and after collision is different. When two objects collide, they repel back, but the velocity is obviously different, maybe. So what will be the momentum after collision? Momentum after collision.
Sir,
Yes.
this conservation of momentum after that it is deleted in our school.
It is not in the chapter.
No, we didn't do it.
It's
Sorry.
We didn't do after this conservation of momentum.
it got deleted.
Okay, it got deleted. No problem. No problem. But let finish it. Okay. Actually, I'm intentionally doing some concepts which are the useful concepts that is being deleted from NCERT. Okay. Only we have to study those part which is in NCERT. No extra. What about your idea? See, in NCERT, a lot of useful concept is being deleted. So if you say only the NCERT content, then it's okay. But in this institution, I'm trying to give you the whole idea and whole concepts, right?
Yeah.
So tell me whether we should only stick to the NCERT or with additions. Let me and tell next day, okay? Discuss with your parents and then we'll do, okay? My motto is that we will be dealing the concept with a standard book. That may be useful, that all these concepts are useful. Got the
Yes,
point?
yes.
Okay. So without wasting time, what will be the conservation after collision? Momentum after collision? What will be? Tell me what will be the momentum after collision? What is the definition of momentum again? M
Product of
mass
mass.
into V1 prime plus mass 2 into V2 prime, right? Clear?
Yes, sir.
Yes, yes.
Now we have already written the momentum in before collision, after collision. So we will just write it again. How we will gonna write it? So I'm writing over here. So see, I may write that P initial equal to P final, its magnitude. The momentum before collision is Pi and momentum after the collision is Pf. So Pi is the momentum before collision and Pf is the momentum after collision, right? So what is the Pi? This is M1 V1 plus M2 V2, that will be equal to M1 V1 prime plus M2 V2 prime. This statement is clear.
Yes, sir.
Now we can rearrange all these terms. Take this M1 one side and M2 another side. So if we will common M1 V1 minus M1 V1 prime, this will be equal to M2 V2 prime minus M2 V2. This statement is clear.
Yes,
Avani, this statement is clear to you.
yes, sir.
What about Munir? Rumaza, are you getting this statement? What we will do now? We will make M1 common. V1 minus V1 prime. This is equal to M2 into V2 prime minus V1 prime. Right? So if we want to write V1 minus V1 prime, this is much mathematics, just to understand, nothing else. Clear?
Yes, sir.
So V1 is initial velocity before collision. Sorry, V1 is initial velocity of mass 1 before collision in another way. And V prime 1 is the final velocity, velocity after collision related to mass 1, right? So if you further want to make it, using these relation, we can calculate the velocity of each of the objects. So if we want to calculate the initial velocity before collision, then it will be V1 prime plus M2 divided by M1 V2 prime. So this is the velocity of particle 1 before collision. This is velocity of mass 1, mass m1 before what? Before COLLISION, right? We can similarly find the velocity of final velocity as well. Okay, if we know the initial velocity, we can find the final velocity after collision. Final velocity means after collision for one and the two, both of the objects. Okay, so as you said that, and we know that this concept is being deleted, so we won't go in the details, right? But let me know, all these calculations are understandable to you or not? Abani and Rumeza, what about Munir? These calculations, this mathematics is understandable to you?
Yes, sir.
Yes, sir.
So can you redo it, or you may write it down? Okay. Did you retain it? Will you write it down or take the screenshot, whatever is visible? We started from here, right? Munir, Rumeza, Abani, what about you? Did you get the point?
Yes,
Sir.
sir.
Okay, so there is no confusions.
No, sir.
You understand the concept?
Yes, sir.
Okay, that's good. So we already solved these problems, I think. We solve all these problem. No, this is not the problem. Did we solve this problem earlier?
No, sir.
Okay, so I think this is the different problem. Ah. So are you aware of this distance time graphs? We are
Yes, sir.
studying. Okay. So what about these distance and time graph? What is actually distance? We didn't study these concepts, na? Distance time graph?
Yes, sir.
No,
Yes, sir. Very not.
we didn't. So now tell me, what is distance time graph? How we will define it? First of all, can you give the definition? Have you drawn the graphs in your mathematics class?
Yes, sir.
Yes, sir.
So what does graph tells us? What does graph tell us? What we mean by the graph? Have you seen the graph of sine theta?
Graph of
Sine theta? No.
We didn't
no.
learn this.
Sine 0, 0, like this graph? No? So have you seen the straight line? If you didn't, then I will remove it. Have you seen the graph somewhere of from the stock market
Yes, sir.
like that? That bull type graphs? So these are the two axes. This is axis X, this is axis Y, right? And
Yes.
these points corresponds to the particular value of X and particular value of Y, right?
Yes, sir.
Got the point? And when we connect these 2 points, whenever we will be connecting these 2 points, it gives the nature of variation of a quantity with respect to two axes, right?
Yes, sir.
Here it is the same. The distance is on the y-axis and time is on the x-axis. So when we started our observation, t is equal to 0, this object was at distance x equal to 0, right?
Yes, sir.
Means that we have a table where we have time and we have the position, right? Position is in kilometer, that is distance, right? Time is in seconds. So in the 0, 0, time is equal to 0, position is equal to 0, right? So we can make a point over here. I'm choosing the red pen because it is already in the black. This is now when you again try to observe the observation, you find that this point is over here, right? This point is over here. This point is over here. We are just checking our clock and we see how far we are moved. So suppose this is 10 scale, right? This is 30. In between there will be 30. In between there will be 30. So when we check on the 10 scale, we see that our distance is around 9 kilometers. When we are 10 minutes, then we see that we have covered the 9 kilometer distance, right? Similarly, when we are at 41, we see our distance is 29. When we are at 41 seconds, we see that we have 29 kilometer. This is the 29 kilometer, right? So if we have to now plot, then we will fix the time along the x-axis. See, one more thing. Whenever you are drawing the plot and time is involved, you keep the time along the x-axis, right? This
Yes.
axis, this horizontal axis will be the time axis. And this will be the position axis, that is distance. So we will locate, have you seen the graph paper? Have you seen the graph paper?
Yes,
sir.
sir.
Yes, sir.
So you will find that the graph paper has horizontal and vertical lines making a small squares. Okay. And then one box you will find there will be 100 box. In one box, one large box, there will be 100 small boxes. So each box has unit length. So you will find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over here. Similarly, 10 over here. Okay. So this is not the standard. You may see any purchase the graph paper and see it. So when we are told to locate this point, we will find that this is 0 versus 0, right? X and Y both are 0 at this point, right? Now, suppose this will be the 10 and this will be the 10 in both axes. So now we will have to show 10 on the x-axis and 9 on the y-axis. So 9 will be somewhere here. So we will be extending this line perpendicularly. This will be like this. So this will be now 10,9. So first we will write the x point. This is x and this is y. First we will write x, then we will write y, right? At least we need 2 points to make a straight line, right? So now we will be adding this. What we will be getting? 2 points are always a straight line. So we will be adding the another points on the graph axis and we'll be adding it, right? In this way, we plot the graph, right? Clear?
Yes.
So the book has done in the same way, right? So better now remove all the points. So what is the definition of uniform speed?
When an object travels equal distances in equal intervals of time.
Right. Then we say that it is uniform speed. In uniform speed, we will get a straight line. Got the point? If whenever you see a straight line, in position x time t graph, you say that this is uniform speed, right? Whenever there is a straight line, this is position time, a straight line in position time graph. You may say that with close eye, this is the graph for uniform speed. Clear?
Yes, sir, clear.
Okay. What about non-uniform speed? So
When an
for the
object travels
uniform, yeah, for the uniform speed, you have to put this graph, right? Give the heading, subheading, uniform speed, and makes the straight line graph, right? Clear?
yes,
Okay. What about non-uniform?
when an object travels equal distances in unequal intervals of time.
Okay. So if you will see this graph, okay. So see, from this time interval to this time interval, this is the around 10 and this is around 12, right? And the distance is being covered, distance is being covered this much, right? If you will see these 2 points, 0 to 2, the time difference is again 2 unit, but distance covered is only this much, right? Clear?
Yes, sir.
So in this graph, the distance covered in equal time interval of time is not equal. For equal time interval of time, the distance covered is unequal, right? Got the
Yes.
point? So
Yes.
you may write non-uniform, uniform M is from here, speed, and make this graph. Okay. We already know how to define the speed. Did we discuss? What is the definition of speed? What is the speed? I think we discussed already, na? The speed
Yes.
is distance over time. Distance covered by time taken. By time
Taken.
taken, right? We already discussed this, right? Distance, the SI unit of distance is kilometer and SI unit of time is second, right? So is velocity, dimension of speed or unit of speed is kilometer per second, right?
Sir.
Okay. So this is another way. Distance covered is along the y-axis, and the time taken is along the x-axis. So this is nothing but slope. It is nothing but slope. Slope between position and time. Clear? What is the slope? How you define the slope? Have you seen the slope? Ramp. Have you seen the ramp in your daily life? First of all, Riaz, you on the camera, Avani and Munir, Rumaiza, all of you open the camera. Okay. Have you seen the ramp in your daily life or anywhere? Munir, you
Yes,
two
sir.
on, Rumaiza, you two on the camera. So when we see that the slope is steep or slope is one is steeper, right? Like that. One maybe the less steeper. So what does we mean by the steeper slope or non-steeper slope? There might be slope like this, na ramp. You might have seen the ramp somewhere like this, somewhere like this. Okay. So how you will define the slope?
A
It's called,
plane which is moving upright position.
yes. So if we have to find a slope, what we will do? And we will see the y-axis. We will measure this axis and we will measure this axis, y-axis, and then we will divide both and we will get a finite quantity, right? In this way also, in this examples, we will measure the y-axis, what is the distance of hour to hour, and then time, this axis, okay? And then when will we define the two? Then that is the distance in y-axis, distance along y-axis, along y divided by distance along x, right? So when we will divide these two quantities, this will give you the slope. And the slope in position time graph gives the velocity. So my point to make over here, slope in position time graph gives the velocity. Clear?
Sir.
Slope in position time graph gives the speed or velocity. So this is the point. Slope, SLO, sorry, I have written the wrong spelling. Slope in position time graph gives velocity or the speed, right? Clear? Now see one example. See one example. This is very easy, okay? This graph is bit easy to understand, right? So how we will do, if we wanna calculate the velocity of object from A to B, okay, velocity of object, velocity of object from A to B. This is A to B. This graph is visible.
Yes, sir.
This point is A and this point is B, right? So if we have to calculate this is the problem to given to you, and you are being asked to calculate the velocity. Okay, how you will proceed? The velocity of object from A to B. How you will do, Monir? Riyaz, how we will do it? What is the distance along y-axis? What is the object distance along y-axis?
40.
This is the final point 40. Okay, this is the final point 40. So we have to calculate, then we will write 40 minus the B, point at B, okay? And this is A, right? So what is A? This is 29, right?
Yes.
Right, 29. And what about the time?
Time is 40 minutes.
40, this is the 40. This is the 40, okay? This is the
41.
41. I don't know how they have drawn the sketch, okay? Point is given over here, and this they are connecting with the dotted line over here. This is the, I think, NCERT graph, okay? So it is making confused. So what will be the time? The time is over here, right? The final time is 60. 60. And that initial time is like 41. So when we have to calculate the distance between 2 points, we will be subtracting the final position minus initial position, right? Got the meaning?
Yes, sir.
What was the position, final position over here? It was like 40 or whatever it is. Okay, so just keep in mind. The final minus initial. So initial is like this, somewhere over here. So this is our y-axis, the distance along y, and this is the distance along x, right? That is t. 1 minute, it may be. So this is the t, and this is the y. So this slope will give us the velocity. Calculate what is the value of velocity over here for this graph, for this reading. Calculate this value. What happened? Something happened now. The screen is no more.
No, sir, it's gone.
It's gone. Let me see again. Let me share it. Just give me a second. Something from just give me a second. Okay. So finally we are back. Okay. So can you calculate this? Let me once minute. 1 minute. Now it is visible.
Yes, sir.
Can you
Yes, sir.
calculate this sum?
11.
What is
11 by
11 by 19, right?
yes, sir.
So what will be 11 by 19? 11 by 19?
5, sir.
That's 11 by 19. Why this machine is not behaving well today? This is 11 by 19, right? What is happening with me, yaar? 11 by 19. What will be 11 by 19?
We can't simplify.
Okay, we can do. It is less than 1, right? It will be less than 1. Why not? We can do. You are not aware of doing fraction? Sum of fraction? How we do the sum of fraction? This is 11 by 19. I think I have to talk. So this is 11. We will put up decimal, so it will be 110, right? Now read the table of 19. How many time it will be? 19 fives are 95. So it is 95. So almost it is 0.5 meter per second. Okay. The velocity will be 0.5 meter per second, right? Clear?
Sir.
Everyone is clear the concept?
Yes, sir.
Yes, sir.
Okay, so when we will divide the position with time, it will give us velocity, right? Or speed. And the unit of speed is meter per second. Clear?
Sir.
So when is your PT2 or PT3? We have to cover few more concepts, right? When is your PT3 or half yearly exams?
1 minute, sir.
Okay, so kindly share your PT or half yearly, okay? Schedule and syllabus with admin, right?
Okay, sir.
Syllabus and the schedule with admin, so we can arrange your preparation classes or revision classes, right? Or doubt classes, whatever it is. In next classes, we will be dealing with all these graphs, and then we will move on to the circular motion. As the circular motion will be complete, we will be going to the gravity, okay? Gravitational force. Clear? So maybe one more classes.
Okay, sir.
So share your details exam details with admin, right? Any doubt regarding today's class?
No, sir. No doubt.
So what did we study today? What did we study today? What did we studied? It's already over. We studied the conservation law of momentum and then position time graph, right? So now it's time to end the class. Clear? If there is no doubt, we will meet again, okay?